Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So for today, we are still going to discuss the introduction to integral that is on the special focus on the substitution technique of integral. Let's start. Okay, so on the previous video, we have looked at the indefinite integral, and this is the table. So the indefinite integral of 0 is just a constant. Why? Because we are looking at the antiderivative, okay? 1 is x plus c. What about this one? This one, e to the x is e to the x plus constant. Don't forget we have arbitrary constant here. 1 over x is a log of absolute value of x. Don't forget this is the natural logarithm. And k of fx is k times the antiderivative of f, and this one is antiderivative of f plus antiderivative plus or minus antiderivative of g. So this one is the substitution technique. Okay, what is the substitution technique? Yeah, it's only just how do I can change all of the integrand. We usually call the function to be integrate. Function to integrate is integrand. We want to change the integrand to the form that we have known, that is 0, 1, x to the n, e to the x, 1 over x, or something that we know. Okay, yeah. So this one, finding e to the 5x. Okay, yeah. I know the derivative of e to the 5x is 5e to the 5x. So integral of e to the 5x dx should be 1/5 e to the 5x. Yeah. What about this one? Yeah. Okay. It's a little bit more difficult, but if you have already learned about chain rule, this is not too difficult. Okay, so we are going to talk about the substitution technique today. Okay, I will just discuss this using example. Okay, for the first problem, let u equals 5x. So u equals 5x. So du dx is 5. This means du is 5 dx. So 1/5 du equals dx. Okay, so this can be changed into integral e to the u, e to the power of u. What is dx is 1/5 du. So it can be changed into this. Okay, yeah? And constant can get out from integral, so I have this. But this is something that we know. But we usually have integral e to the x dx. But it is all the same. It is all the same. U, X, V, Y, Z is just a dummy variable. It's just a dummy variable. So what is the integral of this? This is just e to the u. So you have 1/5 e to the u plus a constant, arbitrary constant. Don't forget to substitute back what is u. U is 5x. So you have 1/5 e to the 5x plus constant. If you try to find the derivative of this, it will give you e to the 5x. So it is just a simple way to check whether your answer is correct or no. So for the second problem, okay, let's u equals this, 2x squared minus 3. Then as the previous, du should be 4x. du dx should be 4x, and du should be 4x dx. Okay, so 4x dx is du. This is just u. So you have, oh, don't forget the boundary of the integral changes also. This is the boundary for 0, the limit for 0, x equals 0 and x equals 1. So what about u? When x equals 0, u equals minus 3. When x equals 1, u equals minus 1. Okay, yeah. So I have this equals minus 3 minus 1. Why? Because the boundary change, yeah. Okay, yeah. The boundary change. What about this one? This is u. 4x dx is du. Okay, this is just a integral of x dx. What is the antiderivative of x? That is a half u squared. Don't forget, evaluate it at u equals minus 3 until u equals minus 1. So you can have this, and the end you have this. Okay, that's what we usually call substitution technique. So what do we do here? We bring the integrand function to be integrated into the form that we have known. That is this one, integral EU du, this one, integral u du, and so on, and so on. Let's look about, okay, so the point is choosing the right u so that we can solve the integral directly in the new u. But in general, yeah, sometimes it works, sometimes it doesn't. Okay, so let's look about the second example here. So what do you think about u? What should be u? Because this is something that we have, or we don't have this kind of form on the table of integral. Okay, so let's look. Let u equals x plus 1. So you have du dx is 1, so du equals dx. Okay, yeah. If u is x plus 1, so this is will become the square root of u. What is x? X is u minus 1. So you have u minus 1 times the square root of u. But I can multiply this 1 by 1. So you have u times u squared minus u squared du. So this is just u to the 3 over 2 du minus integral u to the half du. Okay, what is the integral of this? 1 over this one times this minus 1 over a half plus 1 u a half plus 1 plus a constant. I can simplify this into this. What is 1 over 5 over 2? This is 2 over 5. What is u? U is x plus 1. X plus 1, 5 over 2. Minus 1 over 3 over 2 is 2 over 3. U is x plus 1 to the power of 3 of 2. Okay, okay. So it's all about choosing the right u. If you are lucky, you can get to the form that we have already known in the table of integral. And that's it. But in general, we cannot solve lots of integral problem. That's why in the coming lecture, we will discuss the second technique, that is the integration by parts technique. Okay, in the next lecture, we will look at how we can calculate it, the area between two curves. If we usually talk about the area between y equals fx and the x-axis, now what about in general between two curves? Okay, yeah, we will talk about that in the coming lecture. Thank you very much.